Okay, children, today I'm going to discuss a very important part in our integration, right? This is integration by parts. Right. So why we are using integration by parts, right? So can you remember in differentiation? So we have a theorem, the differentiation of the two functions which are connect with the multiplication way, right? So this is known as product law of the differentiation, right? So so normally we differentiate it like fx into g dash x, right? dy by dx, fx into g dash x plus gx into f dash x, right? So this is differentiation rule. But here today we have a trouble of integration of the two functions which are connected in the multiplication way, right? But here it is integration. So I fx into gx, right? Two different functions which are connected with the multiplication way. Then how to integrate it? So this is the way, right? This is the problem actually. So how to integrate? So first of all, you just need to understand these are two functions. So you have to select one function as a differentiation function, another one as a integration function. So if you assume this as integration function, so select this as differentiation function, differentiate function. Therefore, you can write I like my method, right? So you just need to follow this method, that's enough. So always integration function, integration value should be multiplied with the differentiation function, diff function, minus integration value into differentiation value. Okay, so this is the way of integrating two functions which are connected in the multiplication way. Right, so in the differentiation we had a product rule. So integration, we have another rule of the integration product, right? So this is the way of integrating the two functions connecting with the multiplication way. Okay, as an example, I will discuss I equal x into ex dx. So follow my steps. So first you have to select a integration function and the differentiation. So what is the suitable one? So x can be integrate and differentiate both. Ex also can be differentiate and integrate. But I'm selecting x as the integration function. Differentiation function. Because if you differentiate x, it will be 1, right? So it's decrease, right? So always select some function which decrease, right? Which decrease in the differentiation, then that is the suitable function as the differentiation, right? So if you integrate x, it will be x squared over 2, right? And again x cubed over 3. So likewise it's getting more power. So then it's not suitable for the integration. So that is why I'm selecting x as a differentiation function, ex as integration function, right? So then I equal integration value, ex integration value is ex, differentiation function, it's x minus Integration value, it's always ex. Differentiation value, it's x. Then I equal x ex minus ex integration is ex plus c. So this is the value of that integration. So if you differentiate this one, you will get this. Right? Doesn't matter. So vice versa, it's work. Right. So let's move to another example. So you just need to memorize this rule, right? So actually this is a theorem in our integration lesson. Okay children, so this is my next example. X cube into len 3x. So how to integrate this? So again, you can see len 3x can't be integrated, no? Len 3x can't be integrated. Then you can select len 3x as differentiation function. X cube as integration. So therefore, I equal differentiation function into integration value minus integration value into differentiation answer. So len 3x, no? 1 over 3x inside the function. Here is 3. 3 getting cancelled. I equal x fourth power over 4 len 3x minus 1 over 4 x cube dx. Right, x cube dx is x to the power 4 over 4 plus c. So 4 into 4, it becomes 16, right? Okay, this is the next example. X squared tan inverse x. So again, you know, tan inverse x can't be integrated. Right? It always differentiate. It can be differentiated. If this is integrate. Integration value into differentiation function minus integration value differentiation answer 1 plus x squared. So therefore, we have a trouble here again. X cube tan inverse x. So what we supposed to do now? So actually we can divide these two functions, right? These two functions. X cube 1 plus x square. This is x cube plus x. Then it's minus x. Therefore, x cube will be this one. So I'm going to substitute it. One plus x squared into x minus x over 1 plus x squared dx. Right, so now I'm going to divide it separately. Here it's x dx tan inverse x over 3 minus 1 over 3. X is x squared over 2. This is 1 over 2 to write the differentiate value of the denominator and the numerator now. Then it's half ln 1 plus x squared plus c. So this is the final answer of that sum. So what I did, I divide x cubed by 1 plus x squared, right? So this is the quotient, this is the remainder. Then I multiplied it and connect using the remainders theorem, right? Remainder theorem. Then substitute over here and divide it separately. And separate means it's isolated to the x and the 2x, x over 1 plus x squared. So this is ln, right? So this is the way of integration, these kind of situations, right? So first thing is you should apply the by parts method. Then after that you can simplify your previous knowledge, right? Okay. Right. So actually you can't use substitution method for the integration by parts, right? If they ask to use the substitution method, it's okay, but without knowing anything, right? So you can't use substitution or something like that. Sometimes children think why we can't use the substitution to some x squared as t, right? So we can, but unable to do because in the exam paper they should provide the guideline to do it. Okay children, this is my next example. I equal tan inverse x dx. So here you can see we don't have two functions, no? Only one function, but can write 1 into tan inverse x. So one should be the integration function, because one can be differentiate, no, it's getting 0. Integrate, differentiate. Integration value into differentiation function minus integration value into differentiation answer. Right, so here the denominator's differentiate value is on the numerator now. X tan inverse x minus half ln 1 plus x squared plus c. Okay, so this is the answer of that sum. Okay, so this is the next example. I equal sine inverse x. So this is 1 integration differentiation. Integration value x, differentiation function, integration 1 minus x squared dx. So how to handle this kind of situation? X over 1 minus. So can you remember my rule number 13? Right. So this d by dx 1 minus x squared differentiate value, it's half into 1 minus x squared minus half inside minus 2x. It's to cancel. D by dx 1 minus x squared square root, it will be minus x 1 minus x squared. Right, so over here we have only the minus sign, except the minus sign, minus x. Right, therefore the value of this x sine inverse x plus 1 minus x squared plus c. Right, so why this is differentiation, that is integration. Okay, this is my next example. X is integration, this is differentiation. Because we can't be integrate now. So integration value into differentiation function minus integration value into differentiation answer 2 ln x into 1 over x. X ln x, right? Therefore, this is again integration differentiation. X squared over 2 integration value differentiation function. So I become minus x squared over 2 ln x plus it's half out, and over here x dx mean x squared over 2 plus 6. So 2 into 2 is 4. Okay, this is my next example. Ex into cos x. How to do it? So you can see both can be differentiated and integrated, right? So therefore, selecting this as integration, this as differentiation. Integration value into differentiation function. Integration value into differentiation answer. It's minus sin x. So over here, again, I'm selecting Ex as integration differentiation. But don't change it, right? Because again you will get the first result. If you change it, you get same the answer. So always follow the same function as the integration function. So why Ex integration is Ex function of the differentiation minus integration value into differentiation value, which is cos x. Right. So what is this? This is also again I know. So I should be integrate it again. Right? So I. Therefore, I'm just taking I equal Ex cos x, Ex sin x, Ex sin x plus cos x is bracket. And here it's I. So I minus I. So I goes to this way, it's 2i. Ex sin x plus cos x. So I become Ex over 2 sin x plus cos x. This is the answer of that sum, right? So these are known as recall function, meaning recursive function. Right, because the same answer is coming recursive. Okay, so I invite you all to do it. Right, Ex sin x integration using this integration by parts. Okay, this is my next example. I equals sec cube x. So how to integrate it? So always sec cube x can be written with sec squared x into sec x dx. So the integration of the differentiate of this, because you know sec squared can be integrated, no? It's easy. Then I become sec squared integration is tan x, differentiation function, minus integration value into differentiation answer sec x tan x. Minus tan squared x sec x. So what is tan squared x? Tan squared x means sec squared x minus 1. Then try to solve the bracket. And I become tan x sec x minus, solve the bracket, it will be sec cube x dx minus sec x. So what is sec cube x, which is again I know, it's going to other side, it's 2y. Minus sec x dx. So the sec x dx means you should multiply both numerator by the sec x plus tan x. The 2y will be tan x sec x minus len sec x plus tan x. So now time to divide by 2 it. I become 1 over 2 tan x sec x len sec x plus tan x. Okay, this is my next example. Right, so what is this? X over 1 minus x square. So can you remember d by dx 1 minus x square, which is half 1 minus x square minus half into minus 2x minus x 1 minus x square. Right. So this is, so if you have minus sign, this whole thing will be integrate function. So this is can be differentiate now. Now follow these steps. Integration value is minus bracket integration value into differentiation function minus integration value differentiation answer. These two getting cancelled now. This is 1. 1 means x plus. Right? It's obviously easy, but you should understand this one. Okay, children. So this is the end of the integration by parts, right? So integration by parts, right? So I think now you might have an idea about the integration parts and why we are using the integration by parts, which is to integrate something, some functions which are connected in the product way, which are connected in the multiplication way. So that is why we are using integration by parts. Okay, then thank you very much for participating, right? So stay tuned, I will upload more lessons, right? And have a nice day. Bye bye.